Hi, Jeff. Good morning.
Hey, Sammy.
So let's maybe give a couple of more minutes and see if people are able to join. So we are kind of stuck on one of the definition. Maybe see whether you have some thoughts on how do we define the load of a system.
Sorry, to define the load, or
Yeah, how do we define a load in a computer system? I think in IUE we said we do need to say the load so that you can compare. But the definition of the load itself, we really need to be more crisp. I think that's the thing. I think I want to spend some time today to figure out how do we define it. Do you have any other opens that you have today?
well, the way I think I would approach it was the issue is that what we don't know when to measure the load, right? So it's and it's going to be, it's obviously very configuration dependent and very user dependent. So it's like, well, if this is if this is this is a virtual machine, container system, it's like, well, if it's, what constitutes what constitutes idle? Is it when you've got no customers running, but there's a there's a hypervisor and then whatever maintenance load is going? Is that the idle? Is what constitutes a load in these situations? But I mean, in my mind, I'm thinking the way I think I would want to measure this stuff would be I would want to maintain here's what my idle reading is, and then anything above that is considered load. And that should remain valid as long as you don't change the hardware configuration. But I think you could dynamically, follow your idle value if hey, if I'm as long as this machine is running, meaning it's in operation, but it's idle, hey, if I record a lower power reading at some point, then that should become my new floor. But that's going to be a question if you've got stuff that's if drives spin down or other things that go into lower power states, how far do we take it to idle? I suppose in those cases, as long as the machine is still able to operate, if it's moved to lower power states, that really should be your lowest, your most efficient idle position. So I guess that still would encourage the correct behavior.
I think so. For ideal power, we have a little bit better definition. What we said is systems infrastructures are ready. Now no workloads running. Until that point, hold on a second.
Yeah.
Yeah, I think Jeff, you were coming at it from a different angle, right? And you're coming at it from a management observation data angle, and I think that may be useful, right? Where, you know, maybe it's more interesting to think of it for practical purposes as the minimum active power, right?
Mm-hmm.
Versus actually trying to define what idle means.
Right.
That's an interesting thing to think about. I hadn't really considered it, right? But that may be more actionable than what Sammy was just describing, right? The problem, Sammy, with the definition we've been using about, you know, initialized and operational, but no workloads running yet, is that assumes that somewhere somebody has a priori knowledge of what that is and can go measure the power. And that's probably a bad assumption.
Come again, sorry, I got a call and disturbed.
I was just saying, I think the way Jeff came at that as a manageability guy is interesting, right? If rather than trying to give some qualitative definition of what idle means, and then trying to mandate that somebody knows how to establish and then measure that condition, right? With a priori knowledge of what's on each system, which they probably don't have, right? Jeff came at it as more of a minimum active power observed so far, right?
Yeah.
And from a management perspective, that's unambiguous, right? I'm going to measure the data, you know, measure the power of the server every whatever minute, 5 minutes, half hour for, you know, all year, every year. The minimum observed load is the idle power. And if I observe a lower one, that'll be the idle power.
So that means when you boot the system, how do you come up with the number there, Jeff? Maybe help to little explain that.
Well, I think Eric just repeated it. I think this, you know, if I'm monitoring power consumption, you know, I've certainly in the past we've absolutely, you know, kept track of peak power because that's where all the concerns were in the, you know, in the past. You know, and I don't know if I've had this bit of chat with you and Eric, but it was the my often repeated, you know, evidence is that, look, you know, folks, the last 20 years, you know, IT systems with their power reporting this was all, you know, this was all done to make sure that the systems didn't trip a breaker. You didn't overload the cooling systems, you know, everything else about the, oh yeah, they can do this for energy efficiency and stranded power and everything else. Like, yeah, that was all just a side effect. You know, so yeah, and I'm sure there's somebody down the way downstream that wanted to use that information and care about it for you know, for efficiency and consumption. But yeah, that let's not kid ourselves. It was done for a very specific reason, and luckily that's useful data. But so yeah, so we absolutely would have tracked, you know, peak power and kept track of that to know, you know, where, you know, because if I need to go put power limits on things, well, then that's really useful, right? So if I've got a rack that's hitting the that I'm concerned is going to hit you know, go above 100% capacity for the rack in either power or thermal, keeping track of, well, you know, there's 20 machines in this rack, but if I look at the peak load of all of them and add that up, as long as that's still below the you know, the maximum, then I know I'm good. And if I want to start applying limits, well, hey, if you've never reached, if you know, if your peak power is 695 watts, if I give you a power limit of 700 watts, then I can allocate power elsewhere, right? So that stuff's all been useful. We can take that same idea and use at the idle size of the like, well, hey, as long as those machines, you know, what's the lowest power they ever got into, as long as they were still in an operational state and ready to take on work. And that's where we probably need to work a definition of, you know, of idle and how you measure it, and agree on that.
So you basically boot after booting the system, or trying to see like where we want to start the measurement. obviously not.
We may need like one other qualifier, right, Jeff, where where it's starting at least some period after a reboot or a boot.
Yeah,
or it's the minimum after observing some value above X.
Right? Yeah, well, it needs to be with the, in an operational state or with the operating system running, words to that effect. But yeah. Boot process completed. I mean, we've got lots of things trying to signal when like, okay, the OS is up and running. And it may be, and we may be able to say that, like, in practice, we may be able to just say after the boot process is complete, because quite honestly, once the system has started loading the OS, it's certainly going to be more active than idle, right? I mean, just the startup process and getting.
Yeah, I think that's the implicit knowledge here that I think we're leaning on, right? Is that if you run a memory test in a PCI enumeration and initialize the kernel, you're going to be above our idle power. And I think as long as that's true,
right?
If we can kind of satisfy ourselves analytically and empirically that that's true, then I think this definition works, right? When you settle back down to some lower power, that's your idle power as far as we're concerned.
So it's a kind of a right definition, but probably we need to put a little more wording. No workloads running, infrastructure services ready.
Yeah.
And the way we measure is minimum active power observed so far after system boot process completed.
Yeah, I think that I think now we're a little bit out of the woods, right? Because the concern has been, we want to kind of latch onto the idle power as an invariant thing while we measure where we are dynamically, right? And I just being a little too, I don't know, too modest maybe. We just talked to Scott Schaefer from your crew, Jeff. And it's evolved a little from what you described, right? Where HPE does a really good job of managing the fan power. That's the other reason you do all this now, right?
Right.
And yes, you actually do need to know, what the power of things and the temperature of things are, so that you can run the fans no faster than you need to. Which obviously varies from system to system and could vary across firmware updates, right? So, as you generate this data, right, you could very well do a security patch or a firmware update or a kernel patch and end up with a different idle power. And Sammy, one of the things we were struggling with is, what if this changes over time? Another thing you could do, obviously, is you could get religion and turn on, features like fast C1E and Core C6, right? And that could change your idle power a lot, right? If you go from all power management disabled to some optimized power mode, you could move idle power by a bunch. It's the whole reason we're evangelizing that you should go do that, right? But ideally, this management system that we establish will notice if you do that, right?
Right.
And so what I like about kind of the way Jeff came at it is, this number could change. It could get worse or better over the lifetime of the system.
Right. Yeah. That totally makes sense. So the peak, we are okay with the workload running. Peak allocatable, allowable power, or do we want to?
Yeah, the only problem with that one is the word allowable, right?
Right. What do we want to say?
That assumes some knowledge about this particular system that may not prove to be true.
We cannot say maximum observed, right? Because you may not never push it, right?
You may have never run a power virus, so you may have never achieved peak utilization. Yeah, I think this one's a little bit tougher, right? Although we could come at it the same way. It could be the peak observed power.
But that's not max, right? Because
it would be peak active, not max.
Right.
And to Jeff's point, right, one of the reasons that we do this, or we know a good fraction of our customers, maybe not every last one of them, overcommit their rack power, right? So if you added up the rated power in all the racks, you're certainly above the rack's power limit, right?
By probably a factor of 2 or 3, right?
Right, yeah. The rated power is some number that you're never going to see, probably, right? And there's a reason for that, because because all the good engineers also established a power cap where if you tried to approach that, it would stop, right?
So do you want to put some wording here, or how do we define that?
Yeah, well, the challenge that we have, maybe there's an intermediate one instead of just the 100% load. Maybe we put aside for a minute, because obviously 100% load would be the peak allowable power, probably, even if that never occurs in the whole life of this system, right? Somewhere right below that is the peak active power, which is something that has actually been observed or is achievable, at least. You're using that allowable word again. Peak active, yeah, right.
So we have both, right? So
Right.
the question is, for this formula, right? For IUE or the definition, we need to pick something, right? Which one we want to take?
Yep.
I would start with your bullet from above. Grab that minimum active power, grab that line, and then change that minimum to maximum.
So peak active power.
Right. Yeah, that would be a good definition of peak active. And then the question is, what about the state where the provisioned or allowed power is higher than the maximum that you've observed so far? Right, which probably happens, right?
Well, yeah, I would expect that peaks continues to be ratcheted up as if you violate that maximum, you've got a new max.
So you're going to want to change 4 to far.
What did he say, Eric?
Oh, you want to change 4 to far, so far. Yeah. Or
So far?
Yeah, right.
Yeah, so what yeah, so then what's that allowable then? Is it because I mean there's a okay, well, if peak allowable power is just if that's the power limit set by somebody, then that makes sense to me, because it's like that should be that's either unobtainable maximums, or it's an artificial, I say that it'd be an artificial limits set by the by the administrator for reasons.
Right. Yeah, and so that word provisioned is important, right?
Yeah.
You may have wanted to keep that. Provision max.
Yeah, I think, Eric, to your point, the peak active power could have exceeded the peak allowable power. And that's a question then of what's your power policy, and what you do about that is a question, but that's not I don't think that's our concern, or it's our issue to solve.
Yeah, well, and the one thing we want to allow for here, Jeff, is Sammy, we don't want to put ourselves in a box where active innovation kind of breaks what we just released, right? Yeah. And we're talking about trying to do, if you do a distributed UPS with supercaps or batteries in the rack, and you do power shaving at rack level, we can allow excursions beyond the provision max, but the transients have a limited duration that you need to enforce. And obviously, if you happen to grab a power sample during the transient, you're going to get what Jeff just described. You're going to get a peak active observation that's above the allowable power.
Yeah, that's true. That's true.
Yeah. And yeah, for the purposes of measurements and efficiency, that's okay. Somebody else may be screaming about it, but from from our perspective, that's a okay.
But when you are averaging it out over a period, then it'll go below that maximum anyway, right?
Yeah, and one thing you could do is change the word allowable to sustainable.
Oh, I get your word. I would use another word just so it's not the sustainable.
Okay, all right.
Yeah, you mean that you mean that one that I could actually survive for more than X amount of time, as opposed to is
a non-transient, right?
Right.
That peak provision power, can we just say it?
Yeah, peak provision will work, right?
Yeah.
And then we don't want to reuse provision in the definition, so we'll have different wording down there.
Yeah, I think the
means
maximum power allocated for sustained use. I used the word again. Damn
it. This definition wise, actually allowable seemed more appropriate to me. I mean,
sorry, allocated. Maybe that's the allocated, not allowed.
Maybe allocated works. Sure.
No, so leave that.
Okay.
Yeah, just
maximum power. Just change the word allowed. Yeah, change that to allocated. And then not sustainable, but sustained. Right.
Sustained use.
Yeah.
Oh, with respect to the term, we changed from peak allowable power to peak provision power. I'm just sort of thinking that sometimes there is a peak provision power, but after that there is a slightly lower limit that might be set for other purposes, and that system can actually only go to that limit that is set. So peak provision power is not really what that system will actually attain at its allowed 100% load. I'm sort of looking at this as allowable power might be lower or equal to provisioned power. So
it depends on how you're using, you're thinking of provision power as design power, right? And we're thinking of provision power, including the management configuration.
Right. What do you mean, including the management configuration?
Meaning if you set a power cap, this is that cap.
Oh, okay. So essentially what I'm thinking as the definition of peak allowable power, you are calling it provision.
However, we're just struggling with wording. I think we're after the same thing. We're just trying to decide what to call it.
Right. Yeah. Okay. I mean, I don't know if it's, but provision is generally the designed from as far as I've seen, and it'll.
Well, we need we certainly need a. What Sammy's trying to do is necessary, right? Where we have the definition language right behind it to disambiguate what it is that we need. So we need to do a good job of that. And then obviously if there's a better word, if we think provision is loaded, it means something else, we'll have to change it. But.
So can I ask you, so according to your definition of provisioned power, what would be peak allowable power then? Would it just be equal to peak provision?
We're trying to get we're trying, those are the same thing. We're trying not to use the word allowable because it implies some a priori knowledge.
Because it implies what?
A priori knowledge. We're after something that is empirical.
I mean, to know the 100% load possible for a system.
Yeah, we haven't gotten to that.
We have not gotten to that load definition. We are still working on the power.
Problem with that one, right? Is we don't have a good definition of it yet because it's not,
Sorry, yeah, maybe I'm jumping ahead. I'm sort of thinking that this will
Okay.
get used in defining the 100% load, but yes, there is an assumption that there will be some operatory knowledge needed about the system.
And the only a priori knowledge we probably have is the design power, which is unachievable.
No, but in the definition of these metrics, it shouldn't be only the spec power that is used. It should actually be the operational allowed power that is used, right? Because
Right.
because we are relating things to load.
That's why we're after a dynamic wording like provisioned, right? Because provisioning change over time.
Yeah, but provisioning is the design power. That's
in your mind, but not in Jeff's or mine or Sammy's.
Yeah.
So, okay, so let me ask you this. If provisioned is not the design power, then allowable and provisioned is the same in your mind?
Yes.
Then why don't we just use allowable? Because allowable then is the correct
We actually
definition in
thought
your mind as
provisioned
well as
was
my
less
mind.
ambiguous.
Sorry?
We thought provisioned was less ambiguous. We just changed to provisioned from allowable. You're saying you like allowable better because provisioned to you means something else.
Yeah, I think provisioned has like clearly two different definitions within us for itself. Whereas with allowable, at least we are all agreeing that allowable means that's the maximum power that system can take.
No, allowable probably can be more, right? You want to put a limit. For example, your system may be capable of operating even a higher power than how much you want to put a limit on it, right?
Yeah,
that is the provision. The system is capable of, that's the provision in my mind. And the limit that we are putting is the allowable.
So
allowable means maximum part can operate, right?
Yes, correct.
Provision means how much you're capping the capacity. You're not allowing to operate above that limit, right?
So are you saying in your mind, allowable power could be above provision power?
Correct.
Allowable power, like,
correct.
Okay. We just said provisioned is the design.
So for example, if you take a system, right, you can say 300 watts TDP, right? It's possible to push the system above that limit, right? If you want to.
For a transient period of time.
Right.
Yeah, if you want to use this in analogies, talk about cars and speed limits, right? So, the speed limit may be 60. I may say that it's okay to, the governor on the truck may allow you to go to 70 because you may need to violate those speed limits, for short periods of time. And then there's of course, the maximum speed, the actual one you obtained, and then there's some design limits and so forth. So we might be able to use those. Oh, you got it using trucks, just not for the
No, in fact, I was trying to map the load to this kind of analogy terms so that we can map it back into our systems, right?
So just going back to the PowerPoint that was just made. So you are trying to indicate the transient time when the power is actually greater than the design power.
I think we are all after is what is a 100% load when we say there's a power we have to tie it to that, right?
Right.
And well, we're going to continue to talk. We're going to continue to talk past each other as long as you read provisioned as designed, because we are not reading it that way.
No.
Okay, so that is what is that is totally fine. But what threw me off is after that, that's why I was asking you if in your mind, with your definition of provision power, will allowable power be the same as provision? And I know Eric said yes, but Sammy said allowable can be more than provision.
Well, yeah, and I'm not sure I agree with that, right? So we just talked through this, right, where the peak active power is going to be an empirical observation. And you could observe a transient. So the peak active power may go beyond the provisioned power.
Yes, that I understand for peak active power. Yeah.
Yeah, provisioned power is for that system, how much you are putting the limit, right?
Correct. It's
Yeah,
not
we
that's
say
the way
300
that's
watts.
the way we're reading it. And I think Shruti's challenging that we may want to change that word.
Right.
Right, but so provision power is not that transient peak, right? That is
No,
going
it's
to
not.
be it's not exactly. So then
It's the active as a transient peak.
yes,
That's why we just added the sustained word in its definition.
yes, exactly. So that's not the transient peak. Then that means what you're
But it's
trying
not
to inflict by
it's not the design
provision-
power either, right? And,
Yeah.
and so we may need to add the design power as a metric, a number that we associate with a system.
Sure, but what I'm trying to say is if it is not the transient peak, then can we say that in your definition, allowable power should be equal to or lower than provision power? The transient peak is not in that definition, right? Transient peak is the active power definition above.
Yeah, active option. Say I will say
The transient power is not
includes
involved in our discussion. We are talking about the next term of peak provision power. So if transient power is not involved in that, then can we say allowable power is equal to provision power in your definition?
okay. It's a allowable power equal to
Yeah, you may just add a second bullet just to say that, this is commonly used, it may be commonly defined for power limits.
okay.
Sorry, I didn't quite understand the answer to that. So my question was, if transient power is not, part of the second definition, then in your definitions, is allowable power the same as provision power?
Yeah.
It is, right? So then why don't we call it allowable power? Because I'll tell you, like provision power is, at least in one word, is clearly design power. And
None of these are design power in the way that we're defining these.
right, I understand. But what I'm saying is that exact word of provision power is used for a very different definition. It's going to cause a lot of confusion. And there might be in how I'm describing it, there's a provision power. There might be an allowable power of the system that's lower, maybe because the total row power has to be lower or some other, DC kind of constraint. And that becomes the power that system is allowed to sustain at. But yeah, provisioned is, at least in one word, very used for the design.
So peak allowable power.
Here we thought we were all in the same world, and we're not.
Well, yeah. So I'd be so the allowable is I'm concerned that word allow, that's the things about, the transients may, so should we use the word allocated then that we've got down in the definition?
Peak allocated power.
Yeah, just call that allocated power.
Allocated would work, sure. Allocated works.
And then we'll just have to, and we could put maximum power allowed for sustained use. That could work in the definition. Allowed for sustained use.
Upper point.
Allowed.
Because I think that's a better usage of the word allowed, because it's, we're allowing this for sustained use. That's as opposed to allowed for very short periods of time. That's the.
And do we want to use provision somewhere, or we don't need to?
No, I think power limits will. I think folks that say like, look, I'm provisioning power. I'm effectively setting power limits, right? So.
Right.
Yeah, so I think in fact, you could make the including power limits a parenthetical on that if you wanted to. Mm-hmm. Right.
Better here.
I'm okay with that. I think that's better.
Okay.
Yeah.
Yeah, I think when finally when we write it up, then we can do the thing. It conveys the message what we are looking for. Right?
Now, do you want to put a definition here of design power just so that even though it's not something that we're going to care about, but it may be good to have that defined just so that if there's any confusion, folks will understand that, like, no. Yeah, there's it's not design
separate
power.
line item.
Yeah,
You want to put a separate line item, design power. What does that means?
Yeah.
And that's the maximum rated power of the implementation, right? And so that's a spec, right? You could actually look that up.
Exactly. Yeah. Faceplate ratings. That's for example. You look on all your power supplies and it says, rated for 800 watts. Like, okay.
Right.
Okay.
And so you could find that in your inventory.
Yes.
Stuff, right? But you would never observe it, obviously.
Okay. So with this, which one we want to associate with for 100% load? Is a peak allocated or peak active?
I would say 100% load. If you're at 100% load, that's where your peak active power is going to come. The question is, the more
it cannot be maximum observed, right? For
yeah.
Come in, Shruti.
No, I think it was just background sounds.
Okay, that's right.
Yeah, now that we have this framing, we can have the discussion we were trying to have, which is, are we using an empirical definition of 100% load where it matches the peak active that we've been able to observe, or are we after a more qualitative, the peak that you provisioned for is 100% even if you never hit it?
So I think even before coming here, right? What is the definition of load? When we say load, what does that means?
Right. Well, that's what we're trying to decide is which load are we talking about?
Yeah, I think that's why I want to discuss an analogy here. Then see how do we map back to our compute system, right? The way I'm kind of thinking is, if you have a look at the truck or even any any vehicle, right? It can carry a limit. There is a weight limit. Also, you have a volume, right? You basically say like how many people can go or how much. How big you can carry, right? You can carry a lot of balloons. It may not have a lot of weight, but it is full, right? When it's full, it's 100% loaded. But you could say like, yeah, I don't need to fill the whole truck, but I could have a very heavyweight item sitting there. It's occupying only a quarter of truck, but still 100% loaded, right?
Yep.
So you do need to have a density, basically like the volume into weight and how much density you can carry. Then you can say, I'm comprehending both weight and volume, right? And on top of that, I don't know, do you close every item or you need to have carrying people or goods or like, do you need to carry at a particular temperature, hot, cold, and all kind of things there, right? And also it's secure. Or what speed you want to take. And you also need to think about distance travel and directions you're traveling. Like, for example, if you take a Uber, right? It's basically a thing where you need to figure out effective path for you to reach the things, especially when you're carrying people with what do you call carpooling, right?
Yeah.
So if you map it back to a compute system, right? It is not all the workloads are all the VMs are doing the same workload, right? You're running a lot of different things. Some may require a lot of compute, some may require just as long as I get the right things handled, you may not really need a lot of resources, right?
I guess the definition I would throw out is that 100% load is the maximum utilization mix that consumes the most power is what I think what we're after. And that's it's very much load and configuration dependent, right? I mean, if I could take the same machine and I could peak out my CPU by processing data packets, trying to run the 10 gigabit link in and out of my machine. I could probably peg my CPU by doing something, and that'll have some power consumption because of the componentry involved. But I could do this, I could turn the same thing around and say, well, I'm going to have it render render photorealistic animation at 8K resolution and max that CPU out at a much higher rate of power consumption because of the other parts of the because of the bottlenecks in the system. So maybe the word bottleneck can help in there. I don't know.
So does not matter the performance of the system as long as 100% power is consumed. You loaded the system to 100%, right?
We may be getting a little too elegant with our analogy.
Right. Yeah, I mean, it's like, do we care? Because I know that in the past when we were trying to do things like determine what the peak power would be, you would go do some tests to try to stress the system, and knowing things that like, oh well, the CPU is where the changes in utilization of the CPU will definitely move the needle on power consumption, whereas changing utilizations on the network device is not going to move the needle near as much, or perhaps the disk, same thing. But now I would say, well, the way to move that needle the most would be to go pound on the GPU and get that swing to happen. But but that do I care? Just as the hey, I can't throw any more work at this thing. And what's the power observed when I did that? And the issue for us is there's a lot of subsystems and a lot of variability in those subsystems and how they consume power. If this was I think your truck is a decent analogy. Maybe we take something simpler like a pump or a fan. There's only one knob. You make the pump run faster, make the fan spin faster. There's a curve of power consumption. So I know if I turn that knob to 100 to 100%, that I can get those measurements out. For an IT system, there's lots of knobs that you can turn. I could turn them all to 100%, and it still might not tell me the right answer, right?
Yeah, I think that the reason I'm kind of going here is at the end of the day, we are looking for a mileage per gallon or something like that, right?
Yes. Yeah, exactly.
Right. So if you are doing mileage per gallon, if I load fully, you can say like I'm carrying so much weight, so it is able to carry a lot of weight. But let us say I'm in the truck, I'm just carrying balloons. I'm not loading, right? I might able to travel the same amount of distance with less gas. But I'm 100% loaded, right?
Yeah, I'm not sure that this analogy is helping us very much, Sammy. So where are you heading with it? I mean, we could get complete with your truck analogy, but I don't know that helps us.
Yeah, I think what I was trying to see, what is the real finally how we want to use the IUE, right? So we know clearly if it is 0, no workloads are running.
Right.
if it is 1, all the energy is consumed by the workloads, right? And no, if it is 1, that means all the energy goes to the workloads, not a fan or other wasted area, right? It's 100% utilized. Right, so you don't have any wastage in the PSU, you don't have any wastage in the cooling, you don't have any wastage in idle power. So you are going to 1.
Yeah, and I think you just asked and answered your own question, right? So you're not talking about load, you're talking about utilization.
Yeah, yeah. And it's utilization in terms of power, not of the aggregate reason.
Yeah, and we need, so
okay.
Sometimes we conflate those words, but they are different.
Yeah.
Right.
Okay. It's power utilization.
So I think the truck analogy could be helpful when we do talk about utilization, if we need to talk about utilization, right? But
okay, instead of using word name utilization,
for purposes of IUE, we don't care what the utilization is. We care what the power load is.
Exactly. Yeah. But yeah, that may be used. Yeah, I think you're right. I think that analogy may be useful to explaining the variability. Is that so I think Sandy said it correctly. It's like what we're after is the miles per gallon or just the fuel consumption. And yeah, look, I can get to high levels of fuel consumption by either overloading the truck or making it go uphill at high grade or running it, trying to run it 120 miles an hour, right? There's lots of ways to do that. None of those matter in the sense of at the end of the day, it comes down to how much fuel did I use?
Correct. So yeah, so then I think the question is, with the IUE, what we want to achieve that, right? So do we want to, how are you going to deal with the 0 to 1 range, like either utilization from 0 to, let us say utilization is 50%.
Mm-hmm.
Does it mean 50% power consumed, or does it mean something else?
Right.
We all know
yeah,
1 and 0 is,
that is the question exactly. Right. And I think what we're throwing out here, I think, is I'd like to test whether we can do this with just power utilization.
Mm-hmm.
Because we don't really care if the CPU actually hit 100% on the OS kernel meter.
correct.
We care whether the CPU hit its TDP, its max provisioned power. And we know for dynamic voltage frequency scaling or turbo designs, they will absolutely do that. And they'll do that well left of 100% CPU load, right?
It's not just CPU, right? You also want to get 100% on your memory.
Right. Well, we're talking about the whole system. So if we home in on the CPU, we know, at least on Xeon systems, right? Whatever we say the TDP is, we will hit the TDP. You know, with very few exceptions over the years, right? Broadwell didn't always hit its TDP. Sierra Forest doesn't always hit its TDP, but every other Xeon in the history of the world hit its TDP, right?
I think
now, by contrast, right, the system probably provisions 15 watts per DIMM, right, times all 24 or 32 or whatever DIMMs. That will never happen.
Yeah. So I'm basically kind of trying to see if we are able to hit 1, if we can do the right workload landing on the right compute, right? You don't want to have too much horsepower compute, but if it is only utilized small, right? Or even if it is utilized small, you want to make sure that all the power goes there, right?
Well, and I'm testing that, right? So for the CPU, as you know, if we stay with that subsystem for a minute,
right.
Are you going to be happy when all the cores are allocated, even if you're not at TDP, or are you going to be happy at TDP, even if not all cores are allocated?
Yeah, as long as you're full, right?
Yeah,
the density that the truck I was using, right?
Come back to what full means in this context, right? Full is ambiguous.
Right.
And I think for purposes of IUE, if you hit TDP, you're done. I don't care how you hit it.
Yeah, the max is fine. So if it is somewhere in the middle, and if you want to compare the systems, how are you going to compare it, right? That's what we're trying to do.
Yeah, I know. But I'm trying to stop you from going down a bunny trail here on utilizing all the resources, right? Because I'm not sure that it matters, right?
So we don't care what we are running, right? What we are really after is, am I pushing all the power to the workloads?
Well, yes. So for us, right, we are allocating or provisioning or allowing some amount of power. Are you using it all or not? Right. And from an IUE and a data center perspective, we would like you to use all the available power and capabilities on all of these systems before you add more systems and run them all at some lower utilization point, right? Now, the other thing that we're going to go after on IUE is how much, once you're using X amount of watts, how much work do you get done for that many watts, right? Which we'll have to get into later. So an actual efficiency, right? But I don't think we're going to care. Like, I know of, 2 customers that are involved with us here in this work, one of whom allocates every byte of memory exactly once. And once all the memory is allocated, you're done. Even though, that doesn't drive full CPU utilization or TDP, right? And another customer who allocates on average, every byte of memory 1.5 times just to get to 55 or 60% average utilization on the CPUs. And over committing the memory isn't something I think we want to get snarled up in here.
So I think the question here is, do we want to say IUE with the load number, or we just leave it IUE and either you load or utilization? We can change the word load to utilization. How do you want to go here, right? I think that's my basic question. Right.
Yeah. So I think, now we're getting to the actual question we want to answer, right? Which is, what makes IUE better? What makes IUE worse? What do we want it to be? What do we want it to be sensitive to?
Right. Yeah, we were kind of thinking as a load name. I believe we can change it to utilization, measured to utilization, right? But even that
load is actually very strange wording. We should say under load or at some target utilization. Okay. There you go. Although that doesn't translate load into some utilization number yet, right? You still need to add more information to get. So under load, I think, is fine, right? During operation, right? You're not at idle,
right?
Right. And then we want IUE to reflect where you are relative to your peak efficiency, I think. And now we're trying to figure out how to do that.
Yeah, this kind of defines properly, but the question is the definition we want to use for the load here, right?
Right. What is it? Power load or some other load, right?
Right. Even if I put power load, then you're just taking it, dividing it, right? You're not really like comparing the workload performance part, right here, right? Or peak performance. Maybe can we say
load line, right? Your load line is defined as power utilization, right? You have the y-intercept defined as active idle, as defined by power, not defined by something else, because the y-axis is power.
Right. Yeah, this one is blue is power.
And
so, if you do the IUE
here is, what did you think the x-axis was when you drew this?
Now, x-axis is a load. When we say load here,
say more. What did you think load meant when you drew the x-axis?
The maximum performance it can produce.
So performance.
Again, it's a big term.
We should relabel it as performance.
Yeah, I think I can change this one too.
I say, if we mean perf, we should write perf. We should not write load.
Yeah. I think I need this is a bitmap. I need to change it. I will.
Yeah, no, that's fine. I'm just saying. I think.
Yeah.
Because otherwise, the problem is, we can get to where we all know what we mean,
Correct.
but we're going to have to make it unambiguous enough that someone who opens it up knows what it means.
Right. So perf, the problem is like there is no on perf, right? That's a problem for it. Right?
Yeah, and if we're thinking in terms of a benchmark proxy, like spec power,
Right.
yeah, the y-axis, the x-axis is perf, and it's established empirically in the process of running the proxy.
Right.
They don't have some theoretical knowledge of the system. They run it as fast as they're able to run it. Say, oh, that's 100% for whatever reason, right? Don't know why, don't care why, right? The peak achievable performance on this system as it's configured is this number, and then I'll back off by 10% increments back to idle from that peak.
Correct.
So the x-axis is perf, but it's a specific incarnation of perf running this proxy.
Correct.
And I think one of the challenges you're facing here is you're thinking of perf as some theoretical max thing, which could work as long as we define how that theoretical max is arrived at.
So it's maybe the right way to
Yeah, no, I think what's here
right.
is okay. We just have to do more about how we're, and then we can figure out what it is that IUE is going to be measuring as distinct from the percent power load, right?
So maybe there's a question for Jeff here. Is there anywhere we are putting a perf number for a system in at least today's system?
It may be a circular question because I've got folks asking us to go place power numbers to effectively allow provide these numbers. So it's so no, it is not there now. But I think that the goal is, and I think it makes, and I've opened this as a question for the Redfish folks of we have measurements and we've added stuff to kind of do the subtractive parts of this. But it would probably be better to say what's the actual computational power as you've got it there, and just report that. It's probably a calculated one, but it's probably a better calculation than some of the other things we were doing about trying to show the idle losses, and because it will be economically inefficient to try to measure all of the losses. Some of those may be so far in the round off that and they may be static loads. For instance, the LEDs and the ASIC used for the management chips and for the fan controllers have effectively a fixed load on them. I'm not going to try to measure that. Measure that at the lab and just report it. So
I was thinking like a current spec int, right? Not a max spec int. Under current operating condition, here is a spec int rating, or like a speedometer, right?
Or a CPU or something.
Right.
There may be, but I mean, again, those loads are so workload. I mean, I want to say that I've probably seen, efficiency reports on, hey, if this is for under database loads, this configuration is more efficient, and here's the power consumption of this. I don't know if there's been anything in the industry though.
Yeah, even if you have the problem, I think that's what I was putting the direction there, right? It's each VM might be running different things, right? There's no one single thing, right? How do we aggregate the performance of that? Or is there any way to, I don't know, measure the clocks, or I don't know, whatever it is?
Yeah, so my expectation is that there will be an imperfect, and maybe improving over time in terms of fairness. But if I was a, if I was a cloud provider and I wanted to start to charge you for, energy consumption based on your workload of your VMs, I would probably want to do something like, okay, I'm going to take my idle load and subtract that from total power consumption, and that'll give me my total computational power. And then I'm going to divide that up, I don't know, by utilization as reported by my hypervisor. And that's going to be as good as I can get. And then people may come back and say, whoa, my utilization is all based on network traffic. I don't consume that much power as opposed to the other VMs that are sucking up the GPUs. So yeah, like, okay, I'll go do some different curves and calculus on that. But it's at the end of the day, it's like I'm gonna have to be doing some guessing, or at least some educated guessing on how to allocate those things.
Right. Yeah, we're gonna have to pick this up. I
I gotta run too. So
yeah. Okay. Very good. I think we do need to continue the discussion and conclude on it. Yeah.
Absolutely. All right.
Good. Thank you.
Are we meeting next week?
No, I think I'm going to cancel July 4th weekend. I think
very good. All right. You all have a good safe 4th.
You too.
You too.
Yeah. Thank you.